Electrical interlocking of contactors. As we know, electrical interlock is to prevent the other contactor or other motor from functioning if the first one is starting or running. Say for example, this motor, you can start at any motor, let's say motor 1, motor number 2. If you are starting at motor number 1, you cannot start motor number 2 because this is interlocked by motor number 1. So you are going to de-energize first motor number 1, so you can start motor number 2. Even if you start the motor number 2's push button, you cannot start because there is an electrical interlock. Contact is preventing from motor number 1 functioning the motor number 2, or either way. This one is started first, you cannot start motor number 1 unless you are going to de-energize motor number 2 first. So we'll add the components we'll supply. We'll name them as motor number 1 and motor number 2. Let's say for example this is the condition. Control 2 sets of motors. You can start at any motor, however if either started, other cannot be started unless it is de-energized first. Okay, you will make the standard start-stop control for motor number 1 and copy that one for motor number 2. Also the power circuit. You will supply thermal overload later. 2 thermal overloads or 1 overload relay. Standard start-stop, let's say that is the condition only. A simple start-stop. If you are going to apply this one to a conveyor or somewhere that the two motors might overlap their mechanical load or output in a factory or industrial setting. M1, CB2, CB1, okay, let's turn this on. Turn on the CB. Top. So this is the condition of motor number 1. And if we are going to turn on motor number 2, you will see what will happen. Copy, but we are going to change the auxiliary contact to M2. M1, holding contact of M1, holding contact of M2. You can align or whatever. The problem if you are not going to align this one is it will make so many lines. So many line number. You're going to align at least one line. And you can remove this one. Go directly there. And this is, let's say, switch number 2. You cannot label this one as M1 because they don't have the same function. It will not accept also. Let's say M1. Turn that on. See, there is error. So M1 should be associated only with power contacts, auxiliary contacts, and the coil of the contactor. Skip. So you can use any other than M1. You can this one, push button 1, push button 2. Just double click and label. Double click and label. See? and they are functioning together. This is a problem because it is not the condition there. So electrical interlock is not yet present. If we are going to motor number 2, you just copy this one and change the power contacts M2, power contacts M2, and let's say EOR number 2, or overload relay number 2, whatever is your preferred. Some uses the TOR, some uses OL, usually in US standard. You can remove the dots. This is from the old connection. With or without the dots, it's fine. It becomes blue because it is outside the working area, which is only until here. But that's fine as long as that is not red notification. Start motor number 2. Oh, they have the same CB. This is not the operation. They are functioning together. The actual application is messed up. So find the solution. So interlock. Interlock is breaking a circuit. So we will use a break switch. Break switch or break contact is to open. Make contact is to make contact, to make a circuit. Initially open or normally open contact. To turn on, to make a circuit. Normally closed or initially closed contact is to break or open a circuit. So normally open contact to make a circuit or to turn on a circuit. Normally closed contact to break or open a circuit, to turn off a circuit. So you will use a normally closed contact. So you are going to prevent this one from functioning. You are going to turn this off by using the M1 of that contactor, because normally closed contact. You can change this one as CB3. If the motors have different power, so you're going to use 2 circuit breakers here. And in reality, this auxiliary contact is connected here. You have auxiliary transformer. This should be the main CB, either of this one. You have the third circuit breaker as per electrical code. One main CB here connected as your local electrical code requirements. Let me turn this on. Okay. You cannot turn. No current is flowing because that is open. So we are going to reset first this one. So that will be closed again. Turn on. Either way around. So you have to turn that on. So this is a problem. We have to start. We have to stop because the condition states we have to stop first. This one, you cannot do that one. So the condition is to stop. So what we are doing with the first contactor to the other one, we will just copy to the other one. So they are identical circuit, and you just copy them but with different label. So this will be M2. Okay, now we will decide if how many stop push button. It depends on your actual application. You can add another series push button or to stop. Let's say the machine requires some station wherein the operator can operate the stop around the machine, so you can add the normal reset stop button, or how many emergency stop push button you can add, as many as you can, as long as it is safe to emergency stop the circuit. Always in series, breaking the circuit that is normally closed. Contact. Turn again. Okay, stopwise. Okay, so M2 is preventing M1 from functioning because once this one is turned on, that is open, opposite to the normally open contact. Okay, if we are going to use the thermal overload relay, since there are two motors, so we are going to series the thermal overload relay here. It should be dominant stop series here or series at the top. There are two possible connections. It depends on how you're going to present. The best way is near the coil. If you are you have the standard that is usually at the top of the coil, at top of the push button. Some prefers this way, as they can see immediately the connection during the troubleshooting. You can also have this one. Several times in European circuit that I troubleshoot, they have this connection. Overload relay is here. Overload relay is okay, that is possible also. Dominant stop, that is always in series with the coil. And if you have another stop push button here, because you want to separate stop push button, you can have that one. And the emergency stop push button is common. You can have another emergency stop push button. It depends on your requirements. Okay, so what we are doing here, copy, do it on the other side. You want to place it here? No problem. That is still a dominant stop. You see dominant stop? There is only one path of current. Okay. For some reason, that will be placed here. That is not a dominant stop. I remember one troubleshooting we experienced. It was placed here. It will stop, but you can still turn on the push button here. Actual is really different from the theoretical. So here, only one path going here. So that is a dominant stop. Either way here or that one. We will see. We have some connections, overlapping connection, but that is fine. Overlapping means the wires are extended because we move the contact. Simulate the overload relay. Can we turn this on? No, because that is open. Oops, we did not change the overload number here, so we're going to change this one as number 2. simulate TOR. Okay, then they have independent TOR, so you can start the other motor. Simulate TOR number 2. Can you turn this on? No, because that is dominant stop. So what to do? We are going to turn off the circuit breaker. Do not reset the overload relay. In actual, you don't have to reset that one because there are troubles within the system, within the motor, because there are overcurrent, because this is tripping. So do not reset that one, but turn off the circuit breaker immediately. Turn off the circuit, find the trouble of the motor, what causes the overcurrent. Maybe bearing, mechanical, stuck mechanical load, 3-phase, single phasing conditions, one phase is busted. You are going to find first the trouble before turning on the overload relay again. You want to add the signalations for the alarm. So we need the normally open contact of the overload relay and buzzer. Where is the buzzer? Buzzer or lamp. If you need the lamp, you can have the lamp. You can parallel the lamp, but be sure the lamp has a transformer. The lamp, that pilot lamp with transformer inside. You cannot parallel an inductive and resistive load directly. So this should be directly connected here, away from the reset. No interruption from the reset push button. Yes, TOR1. TOR2. In some cases, they will connect that one here. Even though this is turn off. You cannot see that way, but in some cases they will do that one. Usually, if this is key operated, you can have key operated emergency stop push button. You can have another series mushroom type emergency stop push button for security. The key operated is for more security, more safety. Next, you will see. Is this fine? The blue notification is fine. Simulate TOR1. Why TOR1 is not functioning? TOR1. This TOR1. Okay. TOR1. TOR1. What am I saying? TRO. See if there is a wrong label. That was wrong. Okay. So you can start this one because that is dominant stop there. You cannot stop the alarm, so that is the advantage there. Well, if you are going to place that one, you can see the alarm. If you are not hitting first the emergency push button, but only the reset up. Next, turn off the circuit breaker. Do not reset that one. In reality, you're not going to reset that one, but find the trouble. Turn off the circuit breaker. Turn off the whole circuit. Turn this on. Simulate TOR number 2. Again, we have TRO. TRO. That is that. Turn that up. Okay, you can reset. Because we copy this one from the other. Okay. CD3, simulate. Okay, here now. Having the alarm of motor number 2. So this is it, electrical interlock. In reality, we have mechanical interlock, wherein the mechanism of the magnetic contactors, they are installed together. They have mechanical interlock. So in that case, that is a mechanism. If this one is functioning first, a mechanical attachment will prevent the physical functioning of magnetic contactor 2. This one is functioning, there is a mechanical link, that is mechanical interlock. No electrical contact is involved. Usually the old wirings, they have that one, but newly made wiring, usually electrical interlock. They even have multiple electrical interlock here for maximum safety. You can put 2 M2 here, you can put 2 M3 here, but you will add another auxiliary to your magnetic contactors. So in this case, if the motor are not identical, so you have 2 different sizes of overload relay, 2 different sizes of circuit breakers. You can have circuit breaker main here. Based on your local electrical code, you can connect them here. Connect. This will become the main. These 2 are the branches. Calculated based on the current, full load current of the motor. What type of circuit breaker? What type of disconnecting switch? Just refer to your local electrical code. There is the standard in IEEE, IEC. You can also refer to it. We are going to place this one here so that no notification of outside the workspace area. Okay. Now this control can be recycled for forward and reverse, clockwise, anti-clockwise of one motor. Let's say 3-phase motor. So that means you're going to change the power circuit to one motor. that will be for the next video, forward reverse of 3-phase motor. That's all for this video. Thank you and have a happy day.